Okay. Then I'll just start for now. So for this lesson, we are going to go through trigonometry. So trigonometry is actually a very big chapter in A Math. It's split into many multiple lessons. So today we'll be focusing on some of the simple identities and also solving and proving trigonometric equations. Okay, so to give a quick summary of this chapter, first few things you need to know is all the different trigonometric ratios. So we have sine x, we also have cosine x, and last one is tangent x. So you need to know that tangent x is actually sine x, sine x divided by cosine x. And then after that, the other trigonometric ratios you need to know is cotangent x, which is 1 over tangent x. So 1 over tangent x will just be, we can flip the tangent x around, right? So it will be cosine x, the pen, okay. Cosine x over sine x. And then the others will be secant x, which is 1 over 1 over cosine x, and cosecant x, which is 1 over sine x. So the way to memorize this one is that the third letter here and this first letter matches. This is how I usually remember it. Okay. Then some of the identities you need to know for trigonometry. The most basic one is this sine squared x plus cosine squared x is equal to 1. So actually there's 3 different formula that you need to know, but the other 2 can be derived using this first formula. So the second one we get by dividing everything by sine square x. So when you divide this by sine square x, you will get 1. When you divide cosine square x by sine square x, then this one, sorry, my pen is, give me a moment. Okay. So cosine over sine is matching this identity here, right? So here we get cotangent square x. And then 1 over sine is cosecant x. So here we have cosecant square x. So this is the first one you need to know. This is the second one. And then for the third one, the first equation, we can divide everything. Cosine square x. So sine square x divided by cosine square x plus this thing divided by cosine square x will give you 1. Then here we have 1 divided by cosine square x. So sine square x divided by cosine square x will give you tangent square x. And then 1 over cosine is this one, secant square x. So these are the 3 identities that you will need for proving trigonometric identities. Okay. So moving on, this is the first question in our worksheet. So I'll give you a few minutes to try first. Then we can do together after that. Anyone wants to share how they did the first question? You can type in the chat or unmute also can. Okay, so divide by both sides by cosine x. Okay, I get what you mean, but usually when we do proving, there is the way we present our answer is usually we will start either from the right hand side or the left hand side, and then we will manipulate the expression until it looks like the other side. So for example, this question, right, I will start from the right hand side first. So we will say RHS right hand side equals to cosine x tangent x. And then I will change this tangent x to become sine x divided by cosine x. And then because these two cancel each other out, we get sine x. And then we have proved that is equal to the left hand side. So this is usually how we present. It's always either right hand side or left hand side, then equals to something, then equals to the other side. So usually the way we choose which side we start from is, usually I will pick the one that looks more complicated to start from, because if I start from here, sine x, there's nothing much I can do with just a sine x. I need to choose the more complicated side so that there is something to manipulate. Okay, so for part B, this side is more complicated, so I will choose to start from the the left hand side instead. We know that cosecant x is the same thing as 1 over sine x. So I convert it here. And then I'll make the denominator into one fraction. Okay, then after that, I will bring up the sine x on top. And then these two things are the same, so I can cancel it off. And then I arrive at the right hand side. And then for part C, again, I will choose to start from the left hand side. So this thing you should have learned in your E-math, the expansion of a plus b squared. It will give you a plus 2ab plus b squared. Similarly for here, a squared minus 2ab plus b squared. So these two will cancel off. Then we get 2 plus 2 cotangent square x. So I factorize out the 2 from here. And then you realize this one is similar to the identity we saw just now over here. 1 plus cotangent square x is the same thing as cosecant square x. And cosecant square x is the same thing as 1 over sine x. So this is, we arrive at the right hand side. Any question? Okay. Then we can move on to question 2. I'll give you some time to try out first. Oh, how did the cosecant become sine at the last part? Because we learned over here that cosecant is the same thing as 1 over sine x, right? Over here. Okay. One D. Okay, which part do you not understand? Which step? Step one, like from here onwards. Okay. So what I did here was the denominator, I made it into one fraction. So 1 plus 1 over sine x is the same thing as sine x over sine x plus 1 over sine x, right? And then because now they have the same denominator, I can add them to combine into one fraction. So that's why this is the new denominator. And then after that, I took 1 plus sine x divided by sine x plus 1 divided by sine x. So when we do division of fraction, we can change this to multiply, and then this fraction will flip around, right? So we get 1 plus sine x times sine x divided by sine x plus 1, which is the same as what we have over here. Yes, sine x, the bottom part of the fraction for this one, yes, because we see the denominator here is sine x. So when we want to add fractions, we must make the denominator the same. Okay, I'm going to start going through the second question now. So for question 2 part A, I will choose to start from the left-hand side since it looks more complicated. So similarly, this 1 minus sine square x over 1 plus cosine x, I want to make it into one fraction. So I will convert this 1 into 1 plus cosine x divided by 1 plus cosine x. Then, because now they're the same denominator, I can combine them into one fraction like this. Then over here, I see there's like this one here. So I will use the trigonometric identity over here. I'll use this one. Sine square x plus cosine square x equals to 1. So I'll convert this 1 into sine square x plus cosine square x plus cosine x minus sine square x divided by 1 plus cosine x. And then these two will cancel out. So here we have a cosine square x plus cosine x divided by 1 plus cosine x. So in your numerator, you see that both terms have cosine x. So I'm going to factor out my cosine x. And then these two are the same, so we can cancel them out. And then we arrive at the right-hand side. Okay. Any question? Okay, then moving on to part B. Again, I will start from the left-hand side. So if I expand out these two brackets, I will get 1 plus secant x minus cosecant, minus cosecant